Looks like it. Excellent. So Tom, welcome back to the chairs.
Thank you, Lisa, and welcome back to all of you. I hope you got a good night's sleep. Y'all doing well?
Yes. These are not electric chairs, don't worry, Talithia.
I just want to make sure that my earphone's working so I don't have the Carl Larson problem. So we've
named it already, I see.
I don't know why they're calling it the Carl Larson problem, because I also could not hear. So whatever you said those first 7 minutes yesterday were brilliant, I'm sure. The best things you've said.
It was brilliant. It was brilliant.
Excellent. Welcome back, everyone.
Yep.
So glad to see you all.
So I kind of want to start off with a couple of questions. One for you, Cynthia, based on your talk, just something that really struck me. And that is, in a lot of your examples of interpretable machine learning, the list of criteria that was output by the machine was small, right? It was 4, 5, 6 items. So my question is this: is that a function of the way you design the algorithm, or is that just an output of the algorithm that it's small? And you know what I'm saying? Is it intentionally limited to be small?
It's intentionally small. It's not limited. Like, the algorithm can add more terms if it thinks those terms are going to be helpful for prediction performance, but it generally, just to be honest, for most of these tabular data problems, especially in medicine, it chooses to keep the model small, and it can get the same level of accuracy as the black box, even keeping it small. So it does that.
Okay. Have you had an instance maybe where you went, wow, this output that it's giving me, it's too long, it can't be used by a practitioner, we need to go back and adjust things to try to make it better?
Not on a medical problem. Usually the issues with the models for the medical problems are that the doctors look at the factors and they go, why did you include that factor? That doesn't make any sense. And we're like, oh, well, it's correlated with that other thing that you cared about. And they're like, well, we should include that other thing. So it's less about sparsity and more about the actual contents of the model itself. Oh, okay, we've got a audio.
Yes.
Yeah.
Which is that,
So maybe you could tell us. No, go ahead. I can barely hear you. Turn my volume up, though. Pilar, you're going to say something?
Okay. So I did a set of interviews with healthcare practitioners in oncology. And one of the questions I asked them was whether it bothered them in their practice if a machine learned model was a black box to them. And many of them said no, because what they said is, I prescribe drugs all the time that I don't know really how they work, or I do other things in my practice where, there's a practice guideline and I just follow it. So that phenomenon is a phenomenon in medicine, and I think this might be why these black box models can get rolled out, and there's often not huge resistance in the medical communities because they're already accustomed to using things that are black box to them. So
can I respond to that?
Yeah, sure, Cynthia.
Okay, so yeah, you're totally right. But there's a difference between using a database to using a messy database to make a prediction, and a drug which actually uses, obeys some laws of physics. So it's just a very different sort of phenomenon. So those two, even though the doctors are uniting them, that's very dangerous to do that.
I agree.
Gotcha.
No,
Rhema, go ahead.
yeah,
Please.
so I do agree that it's not the same, but it's not. I don't think it's the messiness, because even though the chemical compound is always the same, the human biological reaction to it might be just as messily translating it into therapeutic effect. So the transmission from chemicals to therapeutic effect is going to have lots of unknowns, comorbidities and so on, which make it as messy as from input data to a prediction.
True. So, yes, Professor Dominici.
Yeah, Francesca, thank you. I think that this distinction is important based on what is the scientific question that we are trying to address. And so some models are designed and they need to be interpretable and transparent if these models need to guide us regarding how things work or how to fix something that is broken. So if the question is, why is this drug effective? I need to have, and I wanted to understand the mechanism, I need to have a model that is transparent and interpretable to see all of the different pieces. If what I wanted to do is to trust the algorithm about, okay, this is effective, and just figure out to who should I give it to, then I think it's a different question. And so I do think that going back to interpretable versus and transparent versus black box model, I do think that this dichotomy needs to be discussed within the scientific question that we are trying to pursue or we're trying to address.
Sure, I fully agree with that. I see the point, but I think even trying to figure out to whom should I, prescribe this medicine, or whether I should prescribe medicine A or B for a certain indication, understanding who is this model trained on, what factors is it looking at to make this decision, might actually help a provider know whether to use its output. Like, when is this output making some kind of sense and when it's not? So I think even in those contexts, it could be useful to have an interpretable model.
Cynthia.
So I completely agree with that. I mean, look, if these things worked 100% of the time, you wouldn't need interpretability. It would just work. The problem is where it goes wrong. So let's say you're a doctor, you prescribe some medication to your patient, and the patient dies. You're like, oh my goodness, I have to figure out what happened here. Like, I need to know, because I have a new patient that's coming in tomorrow. They would normally be someone I would prescribe that medicine to. Should I prescribe it or not? So if you're missing that piece of information that you need to make that decision, then how can you be an effective doctor? I mean, if I talk to like a biologist, they would say, no, we understand, some of the biological mechanisms by which some of these drugs actually work. And we're trying to figure out more. We're like desperate to figure that out. So it's not like they're happy with the lack of interpretability either.
Talithia.
I think maybe one of the other issues also is when we think about who is using the model, we give the example of doctors who were overall pretty competent and educated. But if you think about who's using recidivism algorithms, or like how much math and STEM and computer science have they had, the people who are putting models into practice don't have the same background that the developers had. And so even having a model that might be interpretable to us is probably not as interpretable to the general public as we might like to hope it would be. And so we also have to keep that in mind, that, in practice, interpretability may not even be something that the user is even interested in.
Yeah.
Unfortunately.
Rhema, go ahead.
Yeah, so I love what Cynthia is doing, which is restricting and trying to pull what is kind of high levels of correlation to a few features. But I take issue with saying, and I think what it does, the strength of it, is it makes it a very robust model, because you don't have all the kind of challenges of feature degradation that you get when you're feeding it lots of features. But on the other hand, to call it interpretable, because the problem I have when I work with sort of frontline workers in child welfare or homelessness or something, they think what I'm giving them is a causal model. They think this is what makes you. And so I think Cynthia's, in her slides, she has an example, being a man, and I'm sorry if I've got it wrong, being a man 19 to 22, say yes. Like if I give some of my frontline workers that, they would be very uncomfortable, because they'd say, oh, I can't do anything about that. So they think I'm giving them a causal list.
So can I follow up on that? I mean, it seems like the audience, I mean, Talithia made this point, the audience, the users makes a difference maybe in what's the appropriate approach here. Does that make sense, Cynthia?
So everything is domain specific. So if the users want something causal, we're going to provide them something that's causal. And I didn't talk about causal inference in my talk, but I do a lot of work in causal inference. I mean, Francesca knows that. So I mean, it's what the definition of interpretability is. Just it purely depends on the domain. And there are a lot of people who would not consider a model interpretable unless it was causal. And so that's an element that you could incorporate into your model if that was something in the domain that's important to the user.
Cool. We got a question from some Gustavus students about supervised versus unsupervised machine learning. And I am a mathematician, not a computer scientist, so I don't know much about this, but maybe you could answer that student's question and put the work that you all are doing sort of in context with that to help that student and me better understand those terms. Cynthia.
Okay, so supervised is when you have a label, so it's an X and a Y, and you're trying to predict Y from X. And unsupervised is when there's no label, so it's just X. And so what are the questions that you could ask if you want to do unsupervised learning? The typical ones are things like clustering, or dimension reduction, where you try to take the high dimensional data and bring it down to low dimensions and preserve its structure. Those are the kinds of questions. Topic modeling, right? These are the kinds of things you do when you don't have labels.
And do the models that you're working with, the programs that you're writing, do they fit into either of those buckets, neither of those buckets? Are they?
Well, most of the work that we do. Most of the work we do is supervised, just because it's easier to know when you've done it correctly. But we do work on dimension reduction and also density estimation, which is unsupervised. So we're doing interpretable density estimation and trying to get accurate dimension reduction, so that when you take your data and you project it down onto the plane and visualize it, that it retains its correct high dimensional structure.
All right,
I could give an example of supervised learning in a healthcare setting, right? Just to make it concrete. So when somebody gets a big data set that has from say a few million patients of their actual healthcare data, and you want to know who has been diagnosed with type 2 diabetes. So turns out not so easy to figure that out, because there are a lot of people who are diagnosed, but they don't actually have a diagnosis code. So if your algorithm wants to figure that out, it has to look at things besides the diagnosis code. It has to look at things like, maybe who is prescribed medicines that typically treat type 2 diabetes, who had certain lab values, right? So the algorithm is going to look at a lot of different things, but typically it learns because we give it data that are labeled, these people have type 2 diabetes and these people don't, right? And so and then it learns to sort future data into those categories of type 2 diabetes or not type 2 diabetes.
Cool. I want to switch gears just a little bit, and really I would like to start with you, Pilar, if that's okay, because in your last slide, or second to the last slide, you talked quite a bit about how multidisciplinary teams might be one way at getting at the bias issue. And I know that all of you have experienced working with multidisciplinary teams in your work. All six of you have. And so maybe you can address that, how that works, and why, not just why we think that will help, but maybe an example of how it has helped, if we can do that.
So first of all, how it works, I think there is actually some literature on what makes such teams work more effectively together, because it's not easy. And just to give an example of, you need to learn a shared language. And when I was first starting to work with data scientists, and we were actually putting together a grant proposal, we had this really weird interaction where a group of us were sitting around the table, And suddenly someone stopped us and said, I'm hearing at least 3 different ways that the word model is being used. So let's each explain what we mean when we use that word, right? And that's the kind of thing that happens in an interdisciplinary context. And you have to be paying a lot of attention, or that might go right over your head. Like someone uses the word model and you think you know what they're talking about, but actually you didn't, right? So yeah, I think one of the things about it is that it has to be intentional, and it involves being more explicit about the way you're thinking about a problem, which I actually find incredibly useful and helpful for understanding my own assumptions. When you have to be more explicit about your whole thought process. So I'll stop with that and hand it off to others, because I think there's a lot of people have a lot of thoughts.
Wendy.
I think that one of the most, so I've worked with a lot of interdisciplinary groups, and I think one thing that's absolutely crucial is you have to care about the same question. You have to be driven by the same larger question, and you have to realize you can't answer it on your own. And this is why you're working with someone who's different. And one example that I could offer you from my own experience was at Brown, there was a new president, and as the new president comes in, they always say, we want faculty initiatives to come up, but we're going to decide who you all are going to work together. So it was myself as chair of NCM, the chair of computer science, and someone in biostats, and we were to come up with a big data initiative. And we looked at each other and said, we're not going to come together unless there's a question that can't be answered unless the 3 of us work together. And the one that we came up with, which came out from the person in biostats who was working on AIDS, was that I can show a lot of correlations to exist. I can show a lot of correlations are real, but I don't know what's true. And then the other question that we came up with is, even if you know something's true, it doesn't mean that there's going to be action following from it. So what is the relationship between knowledge and action? So we came up with DIAL. I think it was like inference action loop. I forgot what the D was. Was not funded in the end. But it was this great experience of working together with this. And there's been many projects that have emerged from that. And it comes from that larger question that you all care about. You know you can't do it on your own. And you're open to being challenged in your first principles, which is what Pilar has said.
Francesca, and then Talithia.
Yes, and thank you, Wendy. Yeah, that's really helpful. I think that the reality is, and this is unfortunate. I'm wondering, this is something that we should collectively work toward. Is that doing multidisciplinary research, it's hard and requires a lot of time, and it requires actually to every time we teach ourselves about different language, often as a pillar, it's pointing out correctly. And I do think that there is still a disconnect between how much academic institution wanted us to do multidisciplinary research, and sometimes it comes top down, and the time and resources and how incentivized our multidisciplinary research are. And in fact, I think I think this is a huge problem right now in academia, because even for career development and even the junior faculty, sometimes they're not encouraged to do multidisciplinary research, because ultimately to do career advancement, you have to be the best at a specific topic, right? So I think that we are really facing, I would say, even crisis within academia about how do we all realize that the multidisciplinary research is needed and is important to solve problems right now. But I do think that academia has not kept the pace and has been transformed the culture to really implement it in a way that is beneficial for faculty.
Talithia.
I'll add to that. In addition to multidisciplinary teams, we also need people on the front lines who look different from us. And I remember when we were taking care of my father-in-law, who had, diabetes, hypertension, you name it. And we're at the doctor's office, and a doctor's doing his rounds, and this young black guy walks in with his white coat. And my father-in-law sort of sat up like, who is he? And what do you have to say? And he's saying the same thing. You know, you got to eat right. You got to cut this out. Dad started taking notes. You know, he's writing stuff down. And we're like, Dad, that's what we've been telling you. Your doctor's been telling you, you know. And we got home and he's like, we got to go to the store. We got to get, you know, Dr. So-and-so told me. And I was just like, your primary care doctor has told you this same thing. But all of a sudden he identified with this young Black man who was just doing rounds, wasn't even his, you know, his primary care doctor. But it was so important for him to see someone who looked like him, who was giving him instruction, because somehow he felt like, well, if you're telling me, then it must be, you know, then I'm going to take it to heart because you really somehow have my best interests in mind. And that's also important for the public to see those interdisciplinary teams. You know, when we talk about COVID-19 acceptance, part of it is them seeing someone who they can relate to and say, okay, if so-and-so's up there, then I can do it too.
Wendy, I think you had a comment. Yeah.
Oh, I think it was actually Cynthia who had the comment.
Yeah.
Oh, okay. I'm sorry.
Oh, okay.
Cynthia.
Thanks. Sorry. So I just wanted to what Francesca and Talithia said was just totally correct, and it just really resonated. And so the question is, well, how do we fix these problems? And then it's like, okay, well, what's the source of the problems? So, I mean, I claim, and Talithia and Pilar know this already because I sent them a video this morning to watch. But like, I think the academic review process is really causing a big problem, because we have this review process where the quality of reviewing, at least in machine learning, is quite low. And it's been that way for quite a long time. And the problem with that is that you end up with the only people who know how to review are people in these very specific fields. And that keeps people with like broader ideas out. And what that does is it kind of narrows the academic community into these specific areas that are not areas that I traditionally, that I've, you know, until recently have thought, you know, were actually important. You know, a bunch of the areas I thought were really important, like interpretability, was just not even, you know, it wasn't even, there was no box to tick to get a good set of reviewers in a machine learning conference, because it wasn't even one of the topics that was listed. So you just had to go with like supervised classification. And it's like, well, great, I'm just getting a generic reviewer, while that neural networks guy gets a specific reviewer who knows this topic, right? And so I think that's what's keeping people out. And so and diverse people, like people with all different ideas, right? I think that's part of what's keeping people out. And then the solution to that then is to open up new journals and new avenues for publication, like what Francesca is doing with the Harvard Data Science Review, to try to get people to be able to publish more diverse, you know, ideas. So I think these are, you know, the solutions are here.
So I have a follow-up question, and really this comes from the audience, and it's just fortuitous because it fits, I think, very well into this conversation. And it is, what can we do to reduce bias in machine learning, along with increasing participation of people from diverse backgrounds? And, you know, it's not clear to me what the questioner meant by participation, but I want to actually interpret that broadly, both participation in, say, our healthcare system, but also participation as data science practitioners or members of these diverse teams. Anybody want to take a shot at that?
You know, so the first thing I want to say is, you know, there's a tendency for people in the big data world to think that all kinds of bias can be reduced by just adding more data. And that's a correct way of thinking about things when the biases are statistical and the data are noisy, right? And so if you add more data, you can basically flatten out that noise or work around that noise. Adding more data doesn't help if what you're finding is an actual pattern that's really there because of, you know, systemic racism or gender discrimination or something else, right? Adding more data is just going to, you know, bring that pattern out even more. So sometimes an answer might be adding more data. Sometimes an answer might be asking the algorithm to solve a different question, right? Because so this point about participation, there are many big data contexts in which we have captured data from diverse groups of people, but we also might not understand how we're capturing that data in different ways, right? So there are examples of like, well, who has access to the internet? Who has access to cars, right? Like, we're capturing data, but we don't understand how our data capture is patterning those data, right? Without the domain-specific knowledge and the understanding of social inequalities, people can be included, but in ways that are not helpful.
Gotcha. Rhema.
Yeah.
I think, in terms of the bias of the sort of data tools that maybe Pilar is kind of was reviewing in her, I think we have to be careful not to compare it to the idealized world in our head, but the real world of human decision making on the ground. And I have an agency partner I work very closely with, and she says to communities, look, if I wanted to run a racist system and ruin your lives, I would not hire Rhema to come and develop an algorithm. I've got 100 ways to do that in my system, because I have 100 bureaucratic decisions that are being made by street level bureaucrats every day that have zero data, lots of gut feel, and a little dollop of heuristics and bias. That's the mixture being served on a daily basis to communities out there. So to me, I've got to ask myself, sometimes I find the conversations a little bit immature about bias in the use of data tools in the real world, because I just think people have to grow up and see what's happening out there first, and then ask themselves, is this A, the biggest source of bias, and B, is this going to make it worse or better?
Francesca.
So I think also to address your question in terms of bias in both ways, or actually try to address bias both in terms of the algorithmic bias, but also bias in terms of diversity inclusion in the workforce of data science. I do think that making concrete progress into diversified workforce and the engagement, of underrepresented minority and female and different socioeconomic status into the world of data science, and especially in the position of leadership, it's really what is necessary to start addressing the multiple biases that are occurring from the algorithmic bias. And the reason why I'm saying that is because I think, as Pilar is teaching us, is, there are a lot of subtlety of how this bias is present in the data they're collected. And the off-the-shelf solution, collect more data, or is this data representative of the population? It's not really what gets to the bottom of the problem. What gets to the bottom of the problem is having this special lens of people that coming from a very diverse background that are working in the space and are pointing where the problems are and thinking about creative solution. And I think right now we still have a huge problem, because I think at the leadership level, this is still a field by great deal motivated, dominated by white males. So I do think increasing leadership diversity in the field is, to me, actually necessary to equip the leadership with a special lens to identify how deep and ingrained these problems are, to really start thinking about solution, because it's not an easy problem to solve.
Right. Talithia, I have a question for you, because you have experience training or providing support for in your summer camps you talked about in your talk yesterday. But also I know that the face of the Harvey Mudd campus in general has changed dramatically since I was first there many years ago. So can you maybe talk about those success stories a little bit? And I think that our audience would appreciate that.
Yeah, I mean, so I think part of it is really incentivizing departments to take ownership and be successful in the success of their diverse students, right? And so I think currently there's not a structure nationwide that encourages math, computer science, physics departments to graduate more women and people of color. There's no sort of way to acknowledge that. That's great. You got some students through. And so there's really no incentive. There's no way to incentivize that. So I think that on campus, we really made it a priority. We said, this is what we want to do. We want to highlight departments, computer science, for example, who have been successful in recruiting and matriculating women and people of color. And then this becomes the model department for the institution. This is the standard that we need to hold high. In the math department in particular, some of the things that we do are very simple. It could be something as simple as inviting students in your intro course to take the next level course. You did great. I hope to see you in the spring in part 2. Sometimes students were just sort of surprised. They'd be like, oh, you think I should take another class? Okay, I'll sign up. They're adding classes to the schedule. And so the fact that you as a professor can say, I see you as a mathematician and I'm excited to see you in more math classes says a lot to an 18, 19-year-old about how they see themselves. And so having that affirmation, believing that every one of our students could major in math if they wanted to, and my job is to get you through the major if that's what you want to do. My job isn't to keep you away and say, you're not cut out for this. You should probably just go over there to another discipline because you're not a math person. I think that happens all too often in our colleges and universities, where professors become the judge, jury, and execution of the ability of what they perceive the ability of their students to have.
Well, I've got another question, I think, from our audience. And Pilar, I think I want to start with you because it's from one of the examples in your talk. So I guess my question is, it's related to the bias question we've been talking a bit about, and in particular about, one of you said, it doesn't help necessarily to add more data. That's not necessarily a better solution. So the question is, are there algorithms that may be deployed that can then be trained on, say, specific hospitals' data? So it may be better for the population that tends to attend that hospital, say here in Minnesota, in Minneapolis, where we are now, versus one in Auckland or Wellington or New York City or whatever, or maybe even within different boroughs.
So this is a conversation that is definitely going on in at least parts of the machine learning for healthcare world. So there's a really fabulous machine learning person, Jenna Waynes, who at University of Michigan, and she's suggested that the way to optimize machine learning for different healthcare settings is to partially train an algorithm, basically, and then to deploy it in particular healthcare systems and let it learn further on the data from the people in those healthcare systems. And she's proposed that as a possibility. First of all, it raises, if the algorithm is a medical device, this raises like numerous regulatory questions because our device regulation system is not set up to handle that. But setting that piece aside, I think, so it definitely could result in algorithms that are sort of optimized for a particular patient population. And if you can't, it's an empirical question whether those algorithms would work better than an algorithm that was trained on a more diverse training set to begin with, right? And in some cases, probably would work better by doing that. On the other hand, you might also learn some site-specific problems, right? So, and the other thing, and this is, again, there are people in the data science world working on this, is that a patient population of a particular healthcare system can change over time,
Sure.
Right? And the past doesn't always predict the future because things in the world change, including the way doctors practice medicine and so forth. And so figuring out how to make these models robust to those kinds of changes in the world is something that there are people who are working on this, but it's also partly why I think whether we're talking about pernicious kinds of bias or just the accuracy of the model, we need to be auditing these things when we put them out into the world in these high stakes settings, because even if it's not exhibiting pernicious bias, there can be other problems that develop over time in the way the algorithm works.
Rhema?
So I just have a follow-up question, if I'm allowed.
Sure.
Do you think, Pilar, there's also an issue of the way the clinician responds to the recommendations of the algorithm and have differential kind of, there's bias in how the clinicians, right? There was some evidence, I can't remember from where judges overruled recommendations of recidivism tools based on characteristics. I think if it was a man, they were more likely to think the risk was underestimated or something. I can't remember it. But so how do we address that? Because you're talking about as if once you put the algorithm in play, the clinicians just sort of go along with it.
Right. Yeah. Thank you so much for asking that question, because you're absolutely right that if clinicians like judges were to say, well, gosh, I accept this algorithm when it supports what I already believed and not when it doesn't, then the algorithm's not really having, it may have very little impact in changing the practice of medicine. So I actually think we need to do a lot more work in explaining, not necessarily, well, I like the whole explainability and interpretability discussion. I'm fully on board with the idea of interpretability as to the extent possible, but explaining the context and why, that piece that comes after the algorithm itself, I guess, is what I'm trying to say in a very inarticulate way, that we need to do that human work, and we need to do that work of not only labeling the algorithm to explain like when it's appropriate to use it with which group of patients, what are the contraindications, what are the things that it might tell you that you need to be really careful in interpreting because this is not causal. So we need to beef up that part of it a lot. But I think we already know that in, for instance, healthcare, it takes between 13 and 18 years for a good evidence-based intervention to diffuse out into the practice of medicine. And this is one of my concerns about the sort of, the hype and enthusiasm about the learning healthcare system and the implementation of big data science in the learning healthcare system, is that we already have difficulties implementing things when we have good evidence behind them. And so we shouldn't engage in this magical thinking and just assume that when we have algorithms that are, working really well, that's going to transform medicine. Because clearly there are a lot of implementation steps there where we need a lot of research.
Talithia.
This is sort of an aside comment, but at the end of the day, even something like a recidivism algorithm is highlighting a bigger issue, which is that nothing's happening while they're spending time in jail. There's no training. Nobody's being trained with a trade. There's not GED, access to courses and training. And so when people get out, they're likely to recommit a crime because there's nothing to do. And I think that's the underlying problem. I feel like we're sort of coming and saying, hey, here's an algorithm to try to predict this thing. But ultimately, really, we need to find what are there systems that are really helping to retrain individuals so that when they come out, they are no longer, they're productive members of society. Where is that happening? And how do we duplicate that? How do we put effort into making sure that when men and women get out of jail, they're not going to come back because of the training and the resources that we're providing them to help them be successful? We're sort of coming into a broken system and saying, let me try to help you predict who's going to come back to your broken system. And I think that's a problem that I sort of have to sit with as a statistician.
Cynthia, I saw.
Yeah, I'd like to comment on that. So that's a great point. So there's a ton of programs out there to try to do, ton of educational programs, a ton of job training programs, and so on and so forth. Even in Durham, right here, there's programs. The problem is that it's really hard to figure out whether any of these programs are actually effective. And we've been actually doing a causal study, to be honest, to get back to causal, about whether a particular job training program is actually preventing people from lead to less crime being committed. And the answer is, so far we haven't seen it. And I've talked to lots of other people who sort of run these programs, and the problem is that it's either the program is actually not effective, which is really sad because there's a lot of resources going into these programs, or it's really difficult to measure whether the program's effective because you can't control for all covariates. It's really hard to do that. So I just want to point that out. It's not that there's no programs. There's plenty of programs. It's just that we don't really have anything that works or that we know can work.
Well, and one of the reasons for that is because there are both legal and cultural barriers to people who have been in jail or prison being hired, right? And so even if you have the skills, it might, and those training programs are working in terms of transmitting skills and expertise, it might be that no one's going to hire people because they're making those decisions not based on skills and expertise entirely, but on these other things, including whether or not you have ever been in jail or prison.
Rhema.
Yeah, so I guess that what Cynthia is saying sort of makes me feel we have a reason for algorithms to answer Talithia's question, because we might be better at choosing the people for whom the program works if we had a good algorithm. Like we did a study that showed that 50% of the children who were recruited in a New Zealand's highest risk service, a home visiting program, would not have been chosen by an algorithm. They were just chosen on the basis that they met poverty standards. 20% of kids meet poverty standards. That's not it's not a very discriminating way of finding. So sometimes when programs don't work, it's not that they're the wrong programs, it's that they're given to the wrong people. And I think for too long, we keep working on improving the programs. And what big data and algorithms are allowing us to do is to say, let's hold the programs constant and try to change and be more targeted about the people we serve with those programs.
So can I respond to that? So I completely agree with that. And we're using a matching method similar to what Francesca described in her talk, where we're trying to match people with very similar people who didn't get the program. And what we found, at least in Durham, is that the program works for no one. Like there's literally no subset of people that we can identify that it works for. And I'm absolutely certain this is a very well planned, very carefully designed program. And I'm not saying all programs are like this, but and I'm definitely not saying that that my words generalize so far. But I've heard from lots of other people that they've been working on determining whether these anti-recidivism programs are working. And frankly, it's either too difficult to tell or it's not working.
Wendy.
So I think this goes back to the question of what question are we trying to answer. So the difficulties with the prison system and reform have been known for a very, 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 very long time. And I think as well the questions that were brought up in terms of culture, in terms of hiring, et cetera, these are larger questions about policing, like who gets arrested, who's part of this system. And so I think that one question that's on the table, and this is why it's so wonderful to have everyone together, is when does it make sense to use a program? When is the problem the program? When is the program actually working absolutely correctly and showing us a bias within the society, and that's why it's important? And how can we think through this in a larger way so we're not just focusing on one thing? So for instance, again, with the global climate change model, if it says it's going to temperatures going up 2%, we say let's fix the world, not the model. Right. So to what extent can we try to think through all of these together?
Yeah.
Francesca.
So I have a very naive question and just going back, I have a question back to the panel. As I was watching Pilar talk, at some point, Pilar, you had an example of gender bias in the workplace, right? Where you had this classical picture where the assistant were all photos of female and the CEO were all photos of white male, right? So, and so you were saying that you've been monitoring the algorithm and saying that it's getting a little better, but there's still bias. So here's my naive question from just a statistician. So can we? And I know this is a very simplistic example, right? In this context of gender bias in among the CEO and the assistant, but can you train the machine on a hypothetical data set where you enforce that there is no bias? So basically, when you're showing the figure, let's say now I am changing the label, so then under the CEO I have 50-50 male and female, and under the assistant have a 50-50 male and female. And so I modify the data under an hypothetical world where I eliminate the bias. I feed the algorithm. Now I have a kind of baseline of what the prediction should be in a hypothetical world of no bias. And then I calibrate that with respect to what I see. Has this been done? Is this a stupid idea? I like to be naive purposely, so then we can open it, to the discussion.
No, I think it's not a stupid idea. And to my knowledge, and I might not be the best person to answer this, but in limited contexts, things like that have been done. I think an interesting question is, to what extent should we do it? So I kind of tried to raise that a little bit in the talk, right? That what I think that's an example of is a stereotype in society that is being represented by the algorithm. And like I said, the algorithm learns the glass ceiling for CEOs, and that's a real thing in society. If you keep presenting that to people, you can reinforce that stereotype very easily. And so the ethical question is, to what extent do you de-bias that or de-stereotype that? What is that the responsibility of data scientists to do? It's certainly not only the responsibility of data scientists, because the bigger question, I think, as Wendy said, is fixing the world, right? Like when we have a tiny proportion of CEOs are actually women, that's the problem that we need to fix. But just the pictorial representations of CEOs can, at least perhaps at the margins, have an impact on fixing that problem. So I think your question is not a stupid one, and to some extent it has been done, and others maybe can give more examples. But to me, the harder question is, when should we tweak the algorithms in that way, right? When should we tune them to get rid of things like stereotype and bias? And I think when it's actual pernicious bias, the answer is yeah, to the extent that we can go in. And again, I think there are hard problems where it's just not that possible to tune. But if it's a problem where you can, and it's pernicious hiring bias or something like that, I don't see the argument for not tuning, but there might be one.
Cynthia.
So I want to respond to that, Pilar. So to give another example. Okay, so I'm going to repeat the example from my talk. Okay, so let's think about Compass, right? So we don't know what's inside Compass. ProPublica thinks that Compass depends on age, criminal history, and race, at least. Okay, so let us say that my paper's hypothesis is correct, that it only depends on age and criminal history. Okay, so if that's true, then age and criminal history are predicting recidivism. Okay, what's the problem with that? Well, the problem with that is that age and criminal history are correlated with race. Okay, because police. So let's say that police tend to arrest young Black men, right? Okay, so then what happens? Their criminal history goes up. They're younger and they have longer criminal histories. So what do you do with that information? Okay, so you have to decide what factors are actually allowed in these recidivism scores. This is extremely difficult if the model is completely opaque, because you don't actually know what's in the model and you don't know whether those factors are allowed or not. Okay, so let's say that you say, all right, well, we have to allow criminal history because, somebody with a long criminal history, if you've committed, if you've been convicted for a whole slew of crimes, you have a higher risk, and we don't want to grant you bail if you're going to go out and terrorize your neighbors and whoever else, right? So then the question becomes how do you actually do this? But yeah, I guess my main claim is that if you can't tell what the model actually has in it, it's really difficult to have that discussion. What factors are we allowed to use? What should we actually predict here? Yeah.
I
Wendy.
agree. And I actually wanted to push you a little bit on that example because if things in the algorithm, the features that it's actually using to predict on are correlated with race because of racial bias in policing, I would say the algorithm is still using race, right? It's using these other things are partially a proxy for race. It's just that it's not clear to me in that particular example how you would not have race influencing the outcomes of that, because everything that happens in the carceral system, in policing, is so influenced by race in our society that I'm just not sure how you debias those algorithms in any meaningful way. And there might be some, but it's just not a simple problem, right? So I think we're making the same point here. I'm sorry, Wendy, I just talked right over you. So.
Go ahead,
I think
Wendy.
this relates to exactly what you were talking about, because I think what's important for us to realize is that these are proxies for racism. When we say they're proxies for race, we're having a very specific notion of what we're considering. We think that we need to think through that, no, age at time of first arrest is a proxy for racism. And I think this gets to some of the questions that were raised in terms of when does one act and how does one understand this? And again, these interpretable models show us nicely what matters, and to see that the distance between race and racism, or to think through the relationship between race and racism, is absolutely key.
Rhema.
So I'm very uncomfortable with data scientists tweaking models along these lines, but I just wanted to share with you some work we're doing in LA, where we're using the fact that the algorithm, classifies, in this case, children in child welfare, to do what we call a race equity feedback loop. So what it does is allows the system to reflect upon what the algorithm is saying the risk of these children are, and why are we still investigating Black children who the algorithm thinks is low risk. And we're not doing it by pushing it onto the frontline workers who are going to feel very negative about it, but using it as part of a continuous quality improvement or CQI system. I'm happy to share this because I know LA has shared it with the community, got feedback and so on. So this is publicly shared. And I think, so I think rather than tweaking these algorithms, maybe use the fact that we get men and ask and put it back into the system to understand. Now, I do know that, I love the work of Jennifer Ebhart in Stanford and the work she's doing with the Oakland police, but there's been a little bit of commentary that kind of reflecting back has actually not been helpful to changing racial disparities in police stops. So I don't, I hope this is a thoughtful way of using this type of algorithms, but I don't know.
Why don't we turn to another question from the audience? And I think, Cynthia, this one is aimed primarily at you, but I could be wrong. The question is this: does making the algorithms more interpretable make it easier to game them?
Yeah, so I get that question a lot. Actually, yeah, there's a Goodhearts Law or something. What is it called? I don't remember. There's a law for that where if you make it interpretable, then people can game it. I don't think for the problems that I'm talking about, people are not gaming the system. People are not having seizures in weird ways to game. That's not what's going on. And and recidivism too. They're not going to think about the score before they decide whether they're going to commit a crime. Like, that's not what's going on in our systems. I did write a paper a long time ago on rating systems for on like reverse engineering, like rating systems for products. And that would be a case where companies want to know what the rating system is so that they can build better products according to this rating system, right? And then in that case, they should game the system, because if people believe that rating company is actually defining what the quality is of the product, they should tell the company so they can make the best quality product, right? If they want the product to be good quality. But the only reason that doesn't work is if the rating company knows that their rating system's not very good, right? If they know that it's only a proxy for quality, and they just want the companies to kind of produce the best quality product and use this not very good rating system. So I think there's a feedback loop there. So getting back to what Rhema was talking about, I think there's a feedback loop there where if the rating system says, okay, I think this is what a good quality product is, then the companies can make a better quality product. And then, they can say, but your rating system doesn't include this, and our product includes that. And then the rating system will be like, oh yeah, we should include that in our rating system, and then they can have kind of a better loop. This is good for things like loan decisions, right? So like loan scoring systems. If you have bad credit, you're probably not going to get a loan because your rating is going to be low. But if that rating system looks at things like the number of times you've defaulted on a loan in the past, well, great, don't default on a loan. That'll build your credit rating. So I think these things maybe should be designed to be gamed in some sense.
You bring up an interesting point too about credit scores in particular. Since COVID, Washington State has eliminated the use of credit score in your auto insurance. And actuaries, went through the roof. Like, how in the world are we going to figure out how much you need to pay for your auto insurance if we don't know your credit score? And I'm thinking, what does your credit score have to do with what great of a drive? Like, it shouldn't be a proxy, right? But it's almost like in some ways we become kind of lazy. Like, well, if you've got bad credit, you probably don't drive too well either, And so, whereas when you think about when you purchase a house, right? There's that sheet of paper that you have to put your race on, right? They're like, we have to collect this information. And part of that is also quality control. Like, yes, I want to know your race. I want to know about your loan. I want to make sure that you weren't discriminated against, that you weren't sold some type of product. And so I think when I think about solutions, it's not building models that are sort of race blind. It's really thinking about what happens when race is in this model. And does the prediction change once I throw in race and gender? Do I still get the same results? Like, I think that's how we need to start thinking about models instead of getting rid of that information. Because like you say, there's so many variables that are already proxy for racism and proxy for sexism that by leaving it out, we haven't built a better model. We've just turned a blind eye to it. And I think we need to really build models that include race and gender and make sure that the models are equitable in their prediction.
Rhema.
I totally agree with Talithia, because some of our models, when it looks at criminal history, we actually want to tell it that this is a Black man, and so we ignore it because it's not as good a proxy for the kinds of proclivities as it would be if you're seeing the same pattern in a white person. Because when we externally validate our models for Black men, criminal history is not as predictive, for example, of mortality if they're in the homeless system as it is for white men. Why? Because you can almost think of, the pattern is not as informative because of the bias in the system. It's like, suppose we just randomly take Black men to jail and systematically take white men to jail, then the algorithm's going to say, jail history in Black men, I don't know what to make of this because it's just random. Whereas jail history in white men, I can see that there is some proclivity there. And so if we tell the algorithm, no, don't use race, it's going to pool all of those racial histories, those criminal histories, and not be able to see that one is just white, sorry, the pun, white noise, and the other is something informative.
Wendy, I think you had your hand up.
Yeah, so I think just to comment on that part, there is that question of, again, proxies for racism. If you're not looking at race and then using proxies for racism, then that's a problem. But I was going to bring up another point when you brought up Talithia, you brought up the no longer looking at credit ratings and thinking through that incredible actuarial field that is so expensive. And to just say, do we need it? Like when you have a single payer health system in Canada, look at all the money you save by not paying those actuaries, by not deciding who pays $10.50 for this and who pays $12.50 for that. I mean, that's money that can actually go into treating patients. So I think that part of the question we need to ask is, when is this beneficial? And again, what are we optimizing and for whom, right?
Yeah. Great.
Yeah.
Cynthia.
Can I add to that? Thank you.
Yep, you bet.
Okay, so I want to point out that for loan decisions, I don't believe they're allowed to collect race information. And so a number of the companies who are doing credit ratings actually have to create proxies for race so that they can figure out whether their models are racially biased. It's kind of sad
when you close on a house,
way.
When you close on your house, not to get the loan, you've already gotten the loan, but when you close, there is some form you have to fill out that goes to the government to.
I'm talking about credit
at least
ratings.
We did, so.
Yeah, I'm talking about the major credit rating agencies. They're actually not allowed to collect race, so they're actually trying to build race from correlations, which is kind of interesting. And then for example, for credit ratings, they can't use race as part of their decision-making process. For criminal recidivism prediction, there's very clear reasons why you want to remove all of the race information from the system. But I just want to point out that with loan decisions, since they can't collect race, they have to get proxies.
But even the race information, I mean, we're just trying to audit our race information and actually going back to understanding where it came from, who asked it, who reported it. And I tell you what, I mean, there is a bunch of people it's federally mandated race reporting that's being done by third parties, So I challenge us to actually know what the hell's going on in some of our algorithms, because I want to know what the hell's going on in our race features.
Yeah, there's an entire body of scholarship on this, ascribed race versus self-identified race, and the fact that some proportion of people's race changes from their birth certificate to their death certificate. People's race in the United States changes across different censuses because either as a society or administratively, we start defining and thinking about race differently and racial categories differently. There are people in the United States who are basically Black on the East Coast and some other race on the West Coast, right? So race is an incredibly complicated construct. In some ways, I think if we had more direct measures, we ought to be developing more direct measures of racism and other things that really matter. I mean, that's, in health and healthcare, we ought to be looking at the kinds of exposures in life that actually affect people's healthcare. So we're already using race in a way that is not particularly helpful to advancing questions about how to improve people's health.
Right. And I think that is just a great place to leave it for today, or for this morning, rather, because we've got another session this afternoon. I want to thank you all so much for a really, really wonderful conversation. It's been great seeing you again, and I look forward to speaking with you this afternoon. Bye-bye.
Thank you. Bye.
Bye.
Bye.